And the craziest part is, LinkedIn processes trillions of messages a day through Kafka. Trillions!
Trillions? Seriously? That's mind-boggling. What exactly are they using all that data for? Is it just the newsfeed?
Newsfeed is a big part, yeah, but think about everything else. Connections, profile updates, job postings, recommendations, learning courses, it's all event-driven. And if Kafka goes down, the entire professional world basically grinds to a halt. Okay, maybe that's a slight exaggeration, but you get the point.
Okay, so high stakes. But lots of companies use message queues. Why Kafka? What makes it so suited for this kind of massive scale that LinkedIn and others are using it? What breaks if you don't use something like Kafka when you get to that scale?
Exactly. Imagine trying to build LinkedIn's newsfeed with a traditional request-response architecture. Every time someone posts an update, you'd have to notify every single one of their connections individually. That's a fan-out problem from hell. With Kafka, it's fire and forget. The update goes into a Kafka topic, and each user's newsfeed service consumes only what it needs. If Kafka goes down, well, new updates stop flowing. The newsfeed gets stale. People might not see that vital job posting or connect with that new colleague. It's a business continuity nightmare. Think about the lost revenue from premium subscriptions or advertising.
So it's about decoupling and scalability. Makes sense. Let's dig into LinkedIn specifically. How is their Kafka setup architected? I imagine it's not just one giant Kafka cluster.
No way. It's massively distributed. LinkedIn uses multiple Kafka clusters, often segmented by function or region. They have a global data center footprint, and Kafka helps them move data between those centers reliably. They use Mirror Maker to replicate data across clusters. Think of Mirror Maker like a specialized Kafka consumer and producer that's sole job is to copy data from one cluster to another. The crazy part is maintaining consistency across all those clusters.
Consistency is always the killer, isn't it? So they're replicating data globally. What about data locality? Are they routing users to the closest Kafka cluster to reduce latency?
Absolutely. They geo-partition their data. Users in Europe are likely consuming from a European Kafka cluster. This reduces latency and improves the overall user experience. But here's the kicker. What happens when a European user connects with someone in North America? That's where the global replication comes in. The connection event needs to be propagated to both regions.
Okay, that makes sense. Now let's switch gears to Uber. I know they rely heavily on Kafka for their real-time operations. How are they using it differently than LinkedIn?
Uber is all about real-time location data. Every driver, every passenger, every trip generates a constant stream of events. They use Kafka to ingest and process this data for things like dispatch, fraud detection, and surge pricing. Think about the sheer volume of data they're dealing with, millions of trips happening simultaneously around the world.
So it's not just about delivering updates to users, like in LinkedIn's case, it's about real-time analytics and decision-making. What are the challenges of using Kafka for that kind of workload?
Latency is paramount. A delay of even a few seconds can have a significant impact on Uber's operations. Imagine surge pricing not reflecting current demand because the data is stale, or a fraud detection system failing to flag a suspicious transaction in time. Uber uses Kafka streams extensively for real-time processing. They're essentially building mini applications that consume data from Kafka topics, perform aggregations and transformations, and then write the results back to other Kafka topics.
Kafka streams. So they're doing in-stream processing. What about fault tolerance? What happens if one of those Kafka streams applications goes down?
That's where Kafka's exactly once semantics come into play. Kafka guarantees that each message is processed exactly once, even in the face of failures. This is crucial for maintaining data integrity in Uber's real-time systems. They also leverage Kubernetes to manage and orchestrate their Kafka Streams applications. If an application fails, Kubernetes automatically restarts it.
Okay, so Uber is focused on low latency and fault tolerance for real-time analytics. How about Airbnb? What's their Kafka story?
Airbnb uses Kafka for a variety of things, but a key use case is personalization and recommendations. They track user behavior, searches, bookings, reviews, and use that data to personalize the Airbnb experience. For example, recommending properties or experiences that a user is likely to be interested in. This is a huge driver of engagement and revenue.
So it's more about building user profiles and driving recommendations. How does Kafka fit into that? Is it just a data ingestion pipeline?
It's more than that. Kafka acts as the central nervous system for Airbnb's personalization engine. User events are streamed into Kafka and then consumed by various machine learning models. These models generate recommendations, which are then stored in a real-time data store like Cassandra or Redis. When a user visits the Airbnb website or app, the recommendations are retrieved from the data store and displayed to the user. They also use Kafka Connect extensively to integrate Kafka with other systems, like their data warehouse and their CRM.
Kafka Connect. So it's not just about internal systems talking to each other, but also about integrating with external services. What's an example of that?
Think about sending transactional emails. When a user books a property, Airbnb needs to send a confirmation email. They can use Kafka Connect to stream booking events to a service like SendGrid or MailChimp. This ensures that emails are sent reliably and in a timely manner.
Okay, so we've covered LinkedIn, Uber, and Airbnb. They're all using Kafka, but in very different ways. It's clear how crucial it is for large-scale data streaming. But what's the biggest mistake you see engineers making when they start working with Kafka in production? What's the counterintuitive thing people often get wrong?
I think the biggest mistake is underestimating the complexity of managing a Kafka cluster at scale. People often treat Kafka like a black box. They just install it, configure it, and expect it to work. But Kafka requires careful monitoring, tuning, and maintenance. You need to understand the underlying architecture, the configuration parameters, and the potential failure modes. Here's where it gets interesting. People often think more brokers equals better performance.
But doesn't it? More brokers mean more throughput, right?
Not necessarily. Adding more brokers can improve throughput, but it also increases the overhead of managing the cluster. More brokers mean more network traffic, more disk I/O, and more coordination between brokers. At some point, the overhead outweighs the benefits. You need to carefully benchmark your Kafka cluster to determine the optimal number of brokers for your workload. Also, people forget about proper topic configuration. They just create topics with the default settings and then wonder why their performance is terrible. Choosing the right number of partitions, replication factor, and retention policy is crucial for optimal performance.
So it's not just about scaling up, but about scaling smart. What about monitoring? What are the key metrics engineers should be tracking in a production Kafka environment?
The usual suspects: CPU utilization, memory usage, disk I/O, but more importantly, you need to track Kafka-specific metrics like message throughput, latency, consumer lag, and under-replicated partitions. Consumer lag is particularly important. It tells you how far behind your consumers are from the head of the topic. High consumer lag can indicate that your consumers are not keeping up with the data stream, which can lead to data loss or stale data. Under-replicated partitions indicate that some of your data is not being replicated properly, which can put your data at risk in case of a broker failure.
Okay, that makes sense. So what are 3 specific, actionable things a software engineer should do differently after listening to this? What practical advice can we give them?
Okay, 3 things. First, don't treat Kafka like a black box. Invest the time to understand the underlying architecture and configuration parameters. Read the documentation, experiment with different settings, and monitor your cluster carefully. Think of it like a high-performance race car. You can't just jump in and expect to win the race. You need to understand how the engine works, how to tune the suspension, and how to drive it to its limits.
Okay, understand the underlying architecture. What's number 2?
Second, benchmark, benchmark, benchmark. Don't just assume that your Kafka cluster is performing optimally. Use tools like Kafka Performance Tools to measure throughput, latency, and resource utilization. Experiment with different configurations and workloads to identify bottlenecks and optimize performance. Think of it like a chef testing a new recipe. You don't just throw ingredients together and hope for the best. You carefully measure each ingredient, taste the dish at different stages, and adjust the recipe until it's perfect.
Got it. Benchmark everything. And the third thing?
Third, automate everything. Managing a Kafka cluster at scale is a complex and time-consuming task. Automate as much as possible, from provisioning and configuration to monitoring and maintenance. Use tools like Ansible, Terraform, and Kubernetes to automate your Kafka operations. Think of it like building a factory. You don't want to rely on manual labor for every step of the process. You want to automate the production line so that it's efficient, reliable, and scalable.
Automate. Got it. So understand the architecture, benchmark everything, and automate relentlessly. That's solid advice.
Exactly. And if you remember those three things, you'll be well on your way to building a rock-solid Kafka infrastructure.
So to recap, Kafka isn't just a message queue, it's a distributed nervous system for modern data-driven applications.
Precisely. And the secret to success isn't just scaling up, it's scaling smart.